Next, we'll do an example. We'll say, give a proof by contradiction that if 3n plus 2 is odd, then n is odd. And we'll take the 3n plus 2 is odd, and we'll label that p. And the n is odd, we'll label that as q. To prove p then q by contradiction, we assume q is true, so n is even. Then we have n is equal to 2n, and that is by the definition of even. Working that out, we do substitution. We substitute n in for 3. N becomes 2n with that substitution, plus 2, reason being substitution. Scroll up a little. Then we'll simply multiply this out, so we get 6n plus 2. This is multiply. Notice every time I do a line of the proof, I have to give the justification for why I can do that. Once we're here, we can factor. So we factor a 2 out, and this becomes 2 times 3n plus 1 quantity. And this is simply factor. And after we've factored that, then we can notice that, hey, wait a second, this is 2 times some number. Essentially, that is in the definition of even format, because this is 2 times some number. Therefore, we can say that 3n plus 2 is even, which contradicts the assumption that 3n plus 2 is odd. Which means that our p and not q, then f. Therefore, we have proven what we needed to prove, and we are complete at this point. And so all we have left to do is do our very final, therefore, p then q. Because recall, the p then q was logically equivalent to what we had here on the previous line when we have p and negation of q, then false. So that's it. We are done with this example of proof by contradiction for